Hi, I'm Daryl Canada. In part 1 of this video, this plan was used to build a practice boat out of cardboard. In part 2, aluminum is used to build the same boat, and this requires a few more skills. Just as was done with cardboard, lay out the plan on the aluminum. If you want to change the dimensions, that is okay. Be sure that the measurements on both sides of the boat are identical. If you decide to change the dimensions quite a bit, building another cardboard model is a good idea. Small changes can make surprising differences. I draw the lines with a scribing tool. A pin, needle, or other sharp object will do, but do not scribe deeply, as this can weaken the material, and keep the lines narrow. Wide lines can reduce the accuracy when bending and cutting. Now, cut on the red lines as before, including lines HG and IJ. As much as possible, I use a knife and straight edge for cutting. You do not have to cut all the way through. A couple of passes with a sharp knife will score deeply enough to separate the material by bending, similar to cutting glass. Scissors can be used also, but are more likely to cause kinks. Practice cutting on scrap. Unwanted kinks, dents, and bends are very difficult, if not impossible, to repair well with this material. It does not matter what method you use to make the bends. I have made up a simple tool that makes a soft and rounded crease. Remember that this material is brittle and very sharp bends can cause the metal to crack, as can repeated bending when putting the boat together. In these pictures you can see that I clamped the cutout to my bench with a straight edge 1/16 of an inch away from the line to be creased, as my creasing wheel is 1/8 of an inch wide. Clamped underneath is 3 layers of medium weight terry cloth. Usually 3 passes with the tool, each pass a little heavier than the last, gives the amount of crease I want. Too little crease is better than too much. Ease up a bit on the pressure as you reach the end of the material. All 3 bend lines should converge at point C. Whatever method you use to make the bends, it is a good idea to practice on scrap. Your boat should now look something like this. Remember that the centerline crease is from K to C. A to K is not creased. As you can see, the total of all 3 bends is about 90 degrees. When the bow and stern are pulled together, the tension in the material contributes to its strength. The 3 transom parts can now be bent to a bit less than 90 degrees. I have rounded the edges on the metal guide I am using to make the bend so that the aluminum will not be scratched or unduly stressed. Whatever method you use to make these bends, try to be very accurate. Now fasten the bow together temporarily. If you are good at geometry, you won't need the wiggle room or any trimming to fit the transom together. However, unless your measuring and bending are perfect, some trimming is usually required, and it is always nice to have a bit of extra material. I do one side at a time. Try to minimize the amount of bending back and forth while fitting, as the aluminum can crack on the bend line. When you are satisfied with the fit, fasten the transom together by whatever method you have chosen, while considering how to make the hull watertight. If you are using adhesives, they could do the job. If you are using bolts or rivets, silicone caulk works for me. These photos show some of the options you have to complete the bow and get the appearance you want. The easiest method is to glue, bolt, or rivet, as in the first photo. The next group of photos shows how to use a second piece of material to achieve a neater finish. It is not too difficult, but it does take some practice. Again, you must think about leak-proofing. The rounded bow is more difficult, but gives a great look to the boat. The degree of difficulty will depend a lot on how accurate your measuring, cutting, and bending are. I fasten at the top with a small piece of aluminum, and then put a small bead of JB weld bond along the length of the join, after taping it into position. My boat came out okay, and I hope yours did too. But I am going to do one more thing for a nicer finish. I cut one more piece to fit inside the transom. This makes it stronger, look better, and makes waterproofing easier. Note that the bottom of this piece is bent forward, so it extends over the bottom about 3/8 of an inch. Clean up any rough edges with a file or emery paper. If required, dents or gaps can be filled with common automotive body filler. You should now be ready for painting. Whatever finish you use, a thorough wash with TSP and removal of any stray silicone is a good idea. I use automotive enamels in spray cans and follow the manufacturer's instructions. Clear coating for a natural finish is an option. The following photos show other ways to shape the stern, from easy to seriously time-consuming. Watching some of my other videos might help you decide what you want your boat to look like and how you want to power it. At the beginning, I said that some basic skills were required. I realize that I have not always explained in detail all the procedures, but knowing how clever and resourceful you are, I expect that you were able to solve any problems you encountered that were not covered in the video. I invite your feedback on how this project went for you, in particular about how you solved problems with the build and innovations that you came up with. It will be a help to me and to others attempting this build if you post your thoughts and ideas in the comments section. I have found that reading the comments section often answers questions that I have had. I hope your build was successful and that you will watch some of my other videos that include boats like these. Other sites that might interest you include the Science Toy Maker, the unofficial Mammoth and Other Steam Forum, and eclecticspace.net. And by the way, thanks for watching. I appreciate it.